So, hello guys, I'm Krishna Sharan Pandit from AML department. The topic is Introduction to Feature Extraction in Images. So, this presentation, I'll be giving you guys the brief introduction to what is feature extraction and how this feature extraction in images works. Okay, we'll also discuss some fundamental processes in image processing and computer vision. Okay, so first of all, what is feature extraction? So feature extraction is nothing but the process of identifying and extracting important information or features, okay, from an image to represent it in a simple form. That's the basic definition. So what is the purpose of this? The main purpose of this is to reduce the amount of data while retaining the critical information needed for tasks like classification, object detection, and recognition. And suppose imagine we are describing a person. So we usually don't want to mention every detail, but we rather focus on the key features like height, eye color, or hairstyle. Okay, so this is what actually feature extract. This is how feature extraction works. Okay, it mainly helps in data reduction, efficient analysis, and improved accuracy. Okay, yeah. So moving on, common techniques. Before common techniques, we should know why this feature extraction is important. Okay, why do we actually use this? What for? What reason? We use this feature extraction for? So, for example, images contain a large amount of pixel data, okay, which is inefficient for computation. These pixel data are inefficient, are not enough for total computation. So, what this how this feature extraction come into action is the extracted features allow machines to understand the images better. Yeah, we can, for example, if you are describing a room, there'll be suppose if there are bed a table in that room, we'll extract the table and bed as different. We'll extract from the image. We'll extract the bed as bed and table as table. So there is like it helps us to understand. It helps the machine to understand the image in a different or in a well mannered way. Okay, by identifying the pattern. So that's what it said. So it's a critical step in computer vision and machine learning pipelines. Okay, so what are the techniques that we usually use? That is edge detection, text analysis, scale invariant features. These are the three techniques that we commonly use for feature extraction. Okay. So edge detection and gradient based methods. So in edge detection and gradient based method, we have gradient calculation, like the Sobel and Canny operators we use to calculate image gradients. Then we have thresholding thing, then hysteresis thresholding. These are the methods that we used in edge detection and gradient based methods. Then the next textual analysis and statistical features, we have co-occurrences matrices, local binary patterns, that is LBP, and Gabor filters. So these are the things that we use. So what are the types of features that we extract from an image? That is the next thing. So before that, scale invariant feature transform. It is also a method that is used to extract features from an image. So creates multi-scale representation of the image, capturing features at different scales. Then key point detection identifies tables, key points that are robust to change in viewpoint and illumination. Then descriptor generation creates a descriptor vector for each key point representing the local image formation. Okay, these are the things. Then we have surf, that is speed up robust features. There is another feature like integral image, and if it is an efficient way to compute sums of pixel value over regular rectangular areas. Then Hessian based detector detects key points based on the determinant of the Hessian matrix. Then descriptor generation generates a descriptive vector for each key point using Haar wavelet based approach. Okay, yeah. Then application. Before applications, we'll come to what are the types of features like that can be extracted. Okay, there is edges, corners, textures, shapes, color. So edges means we know what is edges, lines or boundaries between regions. Then corners means intersection of edges, textures, patterns in intensity or color. Shape means we know there are different shapes, so yeah. Then color, dominant colors or distributions. That's it. So, coming to applications of feature extraction, it is widely used in object recognition, used in various applications like image search, facial recognition, autonomous vehicles, then image retrieval. We can retrieve features, extract features from an image, enables efficient retrieval of similar images based on extracted features. Yeah, by comparing the extracted features, we can retrieve a similar image. Then medical imaging, used for detection, disease detection, tumor segmentation, analysis in medical image, then scene understanding. It helps to interpret the content of an image by identifying objects, scenes, and relationships. Okay, so these are all the applications that it is widely used and it can be widely applied in by using machine learning and deep learning. So these are some of the applications that is used, how this feature extraction come into action in computer vision. Okay, yeah. So before that, yeah. So this before that, the methods of feature extraction can be classified into two. That is manual method and automatic method. So in manual method, we usually use edge detection, corner detection, textual analysis. Whereas in automation method, we use deep learning techniques like CNNs, then early layer deep edge detection, deep layer deep edge detection, etc., etc. We also use pre-trained models such as ResNet, VCG, MobileNet, etc. Okay. Yeah. Then yeah, even though this is widely in use and this has wide scope of advantages, it still faces some limitation and challenges such as noise sensitivity. We know different type of noise. It can be salt and pepper noise, it can be Gaussian noise, it can be like uniform noise. So these are the some noise. These are so noise is nothing but an interference or disturbances that is created or in an image. It can be due to different conditions. It can be due to environmental condition, it can be due to electrical interference. Okay, doesn't matter. So this noise sensitivity. So these noises may affect the extraction, feature extraction. Then occlusion means if we are extracting feature from an image, that those extracted features should not conflict with the actual feature of that image. Okay, I hope you guys understand what I'm saying. So it should not there should not be a conflict between the actual feature of the image and the extracted feature. Okay, then illumination variation, changes in lighting condition can affect the appearance of features and challenge their robustness. That is environmental condition. Okay, then future trends and advancement. There are still ongoing researches that is focusing on developing more robust, efficient, and scalable feature extraction techniques using deep learning and other advanced methods. Yeah, before questions, I like to say the real life examples of feature detection, then face detection. We know detecting facial landmarks like eyes, nose, and mouth. Then we have object recognition. Then we have medical imaging, extracting features from X-rays or MRIs to detect disease. Then fingerprint recognition. These are all examples. Okay. Then these are some of the questions like what is feature extraction in image processing? Why is feature extraction important? Then what are some examples just now? As I said, how do features help machines to understand image? What is the difference between low level feature and high level? These are the questions that we can ask from this topic. So I repeat again, this is just an introduction to feature extraction in image processing. There is still a lot left in this topic, but I just gave you that guys the introduction. I hope you understood. So yeah, that's it. Thank you. Before that, I'd like to conclude that feature extraction is simplifies complex images data into meaningful information, enabling machines to interpret images effectively. So manual methods are suitable for simpler tasks, while deep learning methods are powerful for large scale and complex problems. So yeah, that's it. So I hope you guys have understood what I've said. So yeah, thank you for your time. Thank you.